All right. So, before we get going here today, we're going to do some housekeeping stuff. So, we're just going to be doing review today and tomorrow. So, if you have any questions, I'll kind of start with those. I've got some other questions I think might be useful to kind of go through, but study for that first exam, which is going to be Thursday. I'll post an announcement about this after class today. I mentioned this, I think, yesterday, but I'll change the time in which it's available so you can log on anytime between 9:30 and 3:30. You'll have an hour and 15 minutes to complete it. It'll look like the quizzes in the sense that it's a combination of numeric, multiple choice, multiple answer, fill in the blank questions. So it should be kind of pretty similar in terms of the structure of those two quizzes. However, I would expect the content to be a little bit harder. So I would, make sure that you kind of review those questions. That's why these study or these review sessions are important because I'll probably try to complicate the questions a little bit from the practice materials as well as the quizzes to kind of give you a good idea about what types of questions you'll see Thursday. Okay. Other than that, what else is due before the end of the day Thursday? That first Canvas discussion, right? And then some of those daily quizzes, the due dates, like yesterday's will be due before we start class on Wednesday tomorrow, and then this is going to be due before that exam, right? And then quiz number two is also due at the end of the day on Wednesday. So unlike the previous quiz, I don't want the answers out there, but once you submit your quiz, you can see which questions you got correct and incorrect. So I would try to rework the ones you got incorrect to see if you can come up with the correct answer. If you want to check in with me via email on those, you can do that, but you're not going to have the complete version um, of that answer key. So for module three and four, I'd really rely on those practice problems and then any problems that we kind of work through today and tomorrow related to those modules. Okay. But once again, you can see the questions. You'll still be able to see what types of questions. You just have to kind of figure out like the ones you got wrong, try to rework them and see if you can come up with a different solution after you're looking at your notes. Um, Other than that, I think that should cover everything. I'll probably mention a lot of this again tomorrow because we'll just continue to do review. Um, and then also tomorrow I'll probably talk about what class looks like after that exam, after we're done with that exam. So we can have some module five stuff that we'll talk about. Not material, but all right. Any questions that people want to start with? And I should mention on the practice problems, I think it was questions 14 and 15. The numbers didn't line up with the numbers that were given in the problem. So I had some old versions and I updated them. So I replaced that file this morning so that the numbers in the question actually match up with the numbers that were used in the solution or the answer key. So if you're working off an old version, kind of re-download that. Okay. Any questions that people kind of want to start with on either of those practice problems? Quiz number one. Nothing. Everybody's ready to take that exam? Okay. Um, I'll go through some questions then that I think might be helpful or might be good ones as you're studying. Okay. So the first one, I'm going to kind of go back to module one, where we were thinking about things like the unemployment rate, underemployment. And so let's think about our unemployment rate. All right. We said that was the number of unemployed individuals. We then had that divided by our labor force, which was composed of employed individuals, but also those that were considered unemployed. Okay. So I don't think this popped up on the quiz. I know we talked about this in class. Uh, and we could think about also how something this change would impact something like the employment population ratio, which was our number of employed individuals divided by our CNIP, or civilized non-institutionalized population. So we'll kind of shorthand this as just thinking about it's like the population. Okay. Also, let's think about our labor force participation rate, which was the number of people in our labor force divided by that population. Okay. So let's assume, right, that I've got discouraged workers. Okay. And I'll add some values to this here in a second. Um, we'll work through the unemployment rate first. Okay. So let's assume I've got discouraged workers, and those discouraged workers, there are 50 of them. Okay. If the number of unemployed individuals starts out as 100, the number of employed individuals starts out as 900, we could calculate that unemployment rate, 100 over 900. Now here, if everything's in decimal form, I need to remember every single one of these ratios. I should be multiplying by 100 to turn it into a percentage. So here we would have kind of a 10% unemployment rate. So technically, right, we want to multiply all of these by 100. Okay. If I have discouraged workers that are equal to 50, I can start to think about how does that impact my unemployment rate? Well, my new unemployment rate, right? If I've got 50 discouraged workers who were previously unemployed but kind of dropped out, they stopped searching for a job. Well, that would mean that my unemployment rate is whatever it was before, right? Or my number of unemployed individuals, but I'm losing those discouraged workers, right? They were unemployed, but they just drop out completely now. So I would subtract them from the number of unemployed. Now, if I'm dividing by my labor force, I'd still have the same number of employed individuals, but once again, the number of employed is going down by 50. Okay? So my new unemployment rate would be 50 over 950, which I'm going to do my calculations over here off the screen. So if I do that, I get what? So 50 over 950, multiply that by 100, I get approximately 5.3%. Okay. So one thing you'll notice is what happened to my unemployment rate. When I have discouraged workers, because they're going to be a larger fraction of my unemployed, as long as we assume that the number of, no, it doesn't even matter, right? So the percent of this numerator, right, that this discouraged worker is going to be will always be, excuse me, higher than the percent that the discouraged workers will be in my denominator. Okay. So I can see here, once I have this discouraged workers, the decrease in my numerator would always be larger than the decrease in my denominator, which would then decrease that unemployment rate. Okay. So that might be one good way to check if I ask you to kind of calculate the new unemployment rate. If you come up with a value, as long as you have any discouraged worker, right? So I can think about this, my unemployment rate with any discouraged worker is less than the unemployment rate prior to having them. Okay. So if I came up with like 20.5, I know I made a mistake somewhere. Okay. Any questions on that idea before we add in some stuff here? Okay. So what are discouraged workers going to do to these other measures, right? Well, the definition of discouraged workers were they used to be unemployed. So when I have discouraged workers drop out, right, stop searching for a job, that won't impact the number of employed individuals in my labor force at all. So that change in my employment population ratio, well, they're still part of my population, they're just no longer employed, so that's going to remain the same. Okay. Now, if I rewrite my labor force participation, remember our labor force is the number of employed plus the number of unemployed individuals. Okay. So once I have these discouraged workers, they were previously unemployed. Now they leave, right? They leave the labor force entirely. So that's going to decrease my unemployment, right? We kind of saw that here, which means I'm decreasing the numerator, but the population I have has remained the same, right? The population isn't the people even searching for jobs. These could be stay-at-home parents. And so if that numerator goes down, these discouraged workers would also lower my labor force participation rate. And then if I did underemployment, it would be a very similar kind of calculation or concept to the unemployment rate in this scenario. Okay. Excuse me. Any questions on that before I keep moving? Or if you think of any other problems you want to see worked through as I'm going through these, feel free to kind of put in the chat or unmute and chime in. Okay. So the next thing I could potentially ask is, let's say we have people in our economy that are retiring. Right? So all of these examples I'm giving you, I could give you slightly different examples, but they're all related to kind of similar ideas. So let's say, once again, I'm thinking about my unemployment rate. And remember, this is the number of employed individuals. Sorry, not the number of employed. I'm talking and thinking ahead of myself. The number of unemployed individuals divided by the number of employed individuals plus the number of unemployed, right? And then let's think about my employment population ratio. That was going to be equal to our number that were employed divided by our population. And then our labor force participation rate was the number of employed plus the number of unemployed, right? That was our labor force divided by population. Okay. So let's assume that I have, and I would probably be a little bit more specific here, but by definition, you can think about this should be implied. Sorry, take a drink. So let's say I have an increase in the number of people who are retiring. How is that going to impact each of these measures? And once again, I should technically have, we're just talking about directional changes here. We're not calculating the actual values, but if we were, we would multiply all these by 100. So if I see individuals retire, that somewhat implies, or I would probably be more specific and say, assume that they were previously employed. So if they were previously employed and then they retire, well, our population hasn't changed. Our civilian non-institutionalized population would remain exactly the same, right? That's anyone over the age of 16 who can work, right? But there's no like upper limit on it. So if people are retiring, unemployment hasn't changed, but the number of employed individuals would go down. Well, if my denominator is smaller here, dividing by a smaller number would then increase my unemployment rate. Right? And it would have very similar, it would have the exact, I shouldn't say similar, the exact same impacts if I was looking at the underemployment rate as well. Now, if they're retiring, my population doesn't change, but the number of employed individuals is going to decrease. So in both scenarios, if we see an increase in the number of people who are retiring, that would lower both my employment and my labor force participation rate. Okay. Any questions on that concept or idea? So I would make sure you know how to think about discouraged workers. I would make sure you know how to think about kind of retired workers. Now, an additional type of question I could ask you, and it would likely be more, it would be related to these two measures. Okay. So let's assume that the number of people newly greater than 16 and like are able and willing to work, let's assume that that's less than the number of people who die. Right? This is sad, but this is what we have, right? Well, if I'm thinking about my employment population ratio, what's going to happen? Right? Well, let's say we've got the number of employed individuals divided by our population. Okay. If I told you that none of these people are employed, they're still in school, and everyone who died, no one was employed. Well, that would mean this remains the same, but my kind of population, right, is decreasing. Smaller denominator would increase my employment population ratio, which even though the number of people who are employed doesn't change, that could still increase the employment population ratio, which is why we talked about it's not like the greatest measure of the health of the economy. Okay. If we had, if we're looking at instead the labor force participation rate, this was kind of the number of people who are in our labor force over our population. So once again, if I assume that none of these people who are now greater than 16 are working, they're in high school or still attending school, so they're not working full time, and then it's less than the number of people who die, once again, my labor force wouldn't change, but my population goes down, we would also see that labor force participation rate increase. All right. So what if instead, I kind of change this a little bit, and maybe it's not, I'm thinking about the number of people kind of here who are dying or the number of people who are kind of greater than 16. Let's say that everyone, um, let's say that everybody who's kind of aging into that population, let's say that they all become employed and that I still have the number of people who are dying being greater than that number. All right, so now I do have changes in employment. So if I think about here, if the population is going down, well, at the same time, everyone who is getting over the age of 16, they become employed. Well, now I kind of see that this decrease in my denominator increases the employment population rate, and this increase in my numerator would also cause an increase, right? And then what if instead I had to kind of a similar thing, kind of these are both working in the same direction. Now, a much more interesting example would be let's assume everybody who is now over 16, times are bad, they're like low man on the totem pole, they are all becoming unemployed. And that everyone who dies was previously not in our labor force. Well, now, if the number of unemployed individuals increases, well, once again, if I'm looking at the number of employed, this wouldn't change. I still have a decrease in my population, so I would still see that increase in the employment population ratio. However, if they're all becoming unemployed, right, if the number of people who die is still greater, my population is going down. Right? I should have drawn this arrow in here. But my labor force, right, is also going up, right? In which case I would still see kind of this increase. So it doesn't really matter if they're becoming employed or unemployed, they're still getting added in, sorry, they're still getting added in to that labor force, right? So I would see kind of the similar directional changes. Okay. Any questions on that before we keep moving? And I could do an opposite one where I flip this sign, in which case if these effects of the numerator and denominator ever go against each other, the answer could be it depends. So the ones we have here kind of look at the examples where we have a definitive answer, but it's possible that we see an answer of it depends. So for example, think about if the population, so let's say I'm looking like here, if the population increases while at the same time the labor force increases, well, this would cause my labor force participation rate. So maybe I should color code these here instead of, well, this increase in the population into the larger denominator would decrease my labor force participation rate, while this increase in the number of employed or unemployed individuals increases my labor force. So in that scenario, they're working in opposite directions. So I couldn't say, or the answer would be I cannot determine what happens to that labor force participation rate. So thinking about changes in that numerator denominator for all three of these measures um, becomes important for thinking about just directional changes as opposed to just calculating the number. Okay.
For the unemployed 16-year-olds, why does it increase the labor force if they're like if they would still be considered like full-time students, so not necessarily looking for work, why are they still counted as part of the labor force?
Yeah, so by definition, if they are becoming unemployed, that means they are searching for work. All
All right,
right.
thanks.
So in practice, just because you're over the age of 16, that doesn't necessarily mean that you're being counted as employed or unemployed, right? So, most often people who are hit the age of 16, we don't count them as unemployed if they don't have a job because they're likely not actively searching for a job. They're likely in high school. But if they did, right, maybe this isn't the United States. Maybe this is a country where people need to work, right, to help feed their families at the age of 16, well, then they could be entering the labor force. They could become employed or unemployed because they are searching for a job there. Remember, I know a lot of times we think about this through the context of more developed countries, but underdeveloped countries, right, we would calculate the same way, and there might not be the same kind of high school system. Does that make sense?
Yes, it does. Thanks.
Okay. And that's where I would have to tell you that they are actively searching or they're not. Right? Okay. I think if there's anything else I want to say there. So we'll kind of move on to some questions more related to inflation, so more kind of like module two stuff. So I'll probably not cover, I've got something we're going to do that'll cover some module four material. But unless people ask questions, I likely won't do a lot from module three today, and I'll probably do a lot more of that tomorrow. So here I've got kind of a set of questions we'll work through that are kind of more related to module two. Okay. So let's say we had a question and I gave you the inflation rate. All right. So I told you inflation is 7%. I also tell you that the CPI in 2005 was equal to 200. Okay. Just to kind of keep this math easy here. Um, if I'm thinking about this was the inflation rate from 2020, sorry, 2004 to 2005, then how do we calculate our inflation rate? Well, it's going to be equal to the change in our consumer price index or the change in prices divided by whatever our price index started out at. All right. So if we're writing this out in the context of just a general form, not specific years, this is always going to be my new time period. This is going to be my old time period. And I should be dividing by the CPI from my old time period. Now here, I can come up with what that change is, but that's going to represent kind of the rate of change, not the percent. So anytime we're kind of calculating the inflation rate as a percentage, which that's what it was given to us as, we would have to multiply this by 100. Okay. So I know this value and this value. I want to find this value. I've got a little bit of work to do. Okay. So if I were to kind of do this, I'm going to work this out in general form. If it was me on the quiz, I would likely plug my numbers in. That makes it a little bit easier to think about how I would rearrange this equation to solve for the thing that I don't know. Okay. So in practice, what we're going to do is we're going to divide both sides by 100. Okay. That cancels. We're going to multiply both sides by this old CPI. That cancels. Okay. We could then think about, I'm now going to add that old CPI in both sides. And I'm going to kind of rewrite out what we now have. So what I now have is my CPI in that old time period plus that CPI in the old time period um, times inflation as a percentage over 100. And then that is now equal to the only thing I was left with on the other side, the right side of the equation, was the CPI from 2005. Well, if I'm have the same thing, right, in both of these, I could pull it out to the front. So if I pull CPI out here, well, that was getting multiplied by essentially 1. Here it was getting multiplied by the inflation rate as a percent over 100. And that should be equal to my CPI in the newer time period. Now, from this equation, I can think about, well, I actually know this. I want to solve for this. So I would divide both sides of this equation by 1 plus the inflation rate over 100. I'd be left with the CPI of the older time period is equal to the CPI of the newer time period divided by 1 plus that inflation rate over 100. Okay. And that's if I have the inflation rate as a percent. So for us, we plug our numbers in. We have what, 200. Our inflation rate was told to us to be 7. Let me do kind of my math over here real quick. So we've got what, 200 divided by 1 plus 0.07 gives us 100. Let me have that entered incorrect. Yeah. So 186.92. Okay. Any questions on that idea? I'm going to add some stuff to talk about here in a second. Okay, so one way to check that I didn't make an egregious error in this calculation is if I have inflation, right? So this is a positive value, what has to be true, right? So if I'm thinking about this equation, and I'll kind of rewrite it down here just to make this point. So if the way that I calculate inflation as a percent is 100 times whatever that change in my CPI was. So I can think about this as new minus old divided by the CPI in that old time period. The only way that I have inflation or that this value is positive is if prices went up or that my new CPI is greater than my old CPI. Right? So if the reverse was, so when I had this value of 7%, I know that I have positive inflation. Hopefully the number I come up with when I'm looking at the old time period should be less than what the current CPI is. Sure enough, it was. I at least didn't make an egregious error. Okay. So I'll show you another way in here in just a second, how you can kind of check yourself to make sure you didn't make a really, enter this in your calculator incorrect or make some kind of really bad error. But what if instead I told you that the inflation rate was negative 5%. I then asked you what must be true about the CPI, and I wouldn't say new and old, I might give you like the actual years. So what must be true about the CPI in 2010 relative to 2009? Well, first of all, just the concept itself, I could look at the math and say, well, the only way this equation is negative is if the old CPI is greater than my new CPI. But I can also think about what does deflation mean? It means that prices have actually went down. So the CPI, excuse me, in 2010 would have to be less than the CPI in 2009, or this value is smaller than this value, giving me that negative inflation or deflation. Okay. Any questions on this idea before we keep moving? So I'll show you one thing that can also help when we're thinking about making these calculations. So I just have an Excel formula pulled up. So, oop, did I miss a chat? No. So this was kind of that equation we had, 200 divided by 1 plus that interest rate over 100, um, to calculate what the old CPI was. So one thing that I would always have written down, if you want to make these intermediate calculations, so like I had in that what I wrote down, like inflation as a percent over 100, if you just want to turn inflation to decimal form right away, that's probably an easier way to do it, right? So I know that if I have the decimal form of inflation and I'm told that the percentage is 7%, I know that's 0.07, right? What if I made a mistake and I forgot to convert this, right? I forgot to convert my decimal form of, or sorry, my percent form of the interest rate to the decimal form, or the percentage, sorry, the percentage uh, form of inflation to the decimal form. Well, first of all, one thing you'll notice, when we were calculating this, the CPI was 186, the old CPI was 200. Even if I don't have, like, what's the highest inflation could be? 100, I mean, I guess not the highest, but if it was like 100%, it would be one. Notice even at 100% inflation, that difference between the CPI is 100 and 200. There's only a difference of about 100, right? If I instead have accidentally, instead of putting 0.07, I put 7, right? I put the percent form here. I'll come up with a CPI that is a lot further away from the CPI in the following year, right? It's now greater than 175. Well, if the inflation of 100% only makes the difference 100, anything less than 100% inflation, that difference should be less than 100. And so if I come up with a value, right, that's further than 100 away from that CPI I was given, I know I made a mistake. Sure enough, I accidentally put in the percentage form here. When we're using this formula, I need to use the decimal form of that inflation rate. Okay. Any questions on that idea? Okay. So another thing I'll point out here. So remember, 200 was my new CPI. Okay. Let's say instead I had deflation, right? Well, what we said is going to be true there is that excuse me, the new CPI should be less than the old CPI, right? Because prices have went down. I can prove this to myself because let's say this was like negative 0.07. Well, now that CPI in the new time period, 2005, was 200. So if I had deflation, my CPI in the prior year, which is what we're trying to solve for, should be greater than that, right? So if we're having deflation and I want to use this equation, I wouldn't be adding in, well, technically I'm adding in that inflation rate, but the inflation rate is now negative. Okay. So just some kind of, I don't know, thinking about some ways to like safeguard and make against making some easier mistakes there. Um, Another thing I'll kind of leave you with, and then we'll kind of move on, is thinking about this was when I was given the new CPI and I wanted to find the old one. Another type of problem I could give you is ask you for the new CPI, in which case we would kind of stop at this step. So my new CPI is always equal to whatever the old CPI was. Oops. Times 1 plus that inflation rate in decimal form. Right. So just, if I gave you different pieces of the puzzle, we could be kind of solving for it this way. Okay. Any questions on that before I kind of move on here? Okay. All right. Um, so the next question I'll kind of set up here and work through is thinking about um, this concept of disinflation. So I want people kind of be careful here. I think there was a little bit of confusion based off of people reaching out about these types of questions. So I'll go through one that looks a little bit different um, than what you saw in the quiz. So let's say I've got, oh, I'm looking at my inflation here, and I'm looking at 2010, 2011, 2012. Okay. I was told the inflation rate here. Actually, I'm going to change these values a little bit. Let's do 6.5. And then over here, I'm going to do 4.2. Okay. I don't know what inflation was in 2011, but I'm told that there was no disinflation in 2011, but I did see disinflation in 2012. Okay. So if I'm asked about what inflation was in 2011, what types of statements can I make? Okay. Well, first of all, in order to have disinflation, it means that I still have inflation in both time periods. So I still should have positive values here, or I don't have deflation. I can't have deflation if I have disinflation because disinflation implies there was inflation in both time periods. So I could for sure say that the inflation in 2011 is greater than zero because if I have disinflation in 2012, that means I'm comparing two positive values, right? Two years of inflation. Now, if I have disinflation, it means that the inflation rate in the current time period, 2012, must be less than the inflation rate in the prior time period. So what we can say in this example, well, if 2012 has to be less than the inflation rate in 2011, I know that that inflation rate in 2011 must be what? Greater than 4.2. Okay. Now, what other statements could I make? So maybe this is like a multiple answer question on the quiz. What else could I say here? Well, if I know that there's, first of all, I know that there has to be inflation here since we had disinflation between the two time periods. But if I don't have disinflation in 2011, what that means is my inflation must be higher than what it was in the prior year. So I could also say that my inflation rate in 2011, because I know there's no disinflation, I know it must be greater than the inflation rate in the year prior. So I could also say that my inflation in 2011 is greater than 6.5. Okay. So if I'm kind of combining these, right, um, not only do I know that it has to be greater than 4.2, it also has to be greater than 6.5, which those kind of two things work in, synonymously, but that's what I would have here. Okay. Any questions on that before we keep moving here? Okay. Um, think about if there's anything else I want to say here. I think that's it. And I could leave out like different pieces here and do similar things, but I just kind of wanted to work through one where that middle inflation rate was the one that we don't know. Okay. All right. Any questions on this idea of disinflation? All right. So where are we at time-wise? Okay. So make sure we have enough time for that. All right, I think I've got one more we'll work through, and then will kind of move on here and look at some newer material. So let's assume um, that I I'm looking at real versus nominal income. And I could do examples where I had real versus nominal minimum wage. But for right now, we'll kind of just think about income or just real value versus nominal value. Okay. So the way that we calculated real income was we took our nominal income and then we multiplied that by the ratio of our prices. Right? So what we actually did here to adjust for prices, right? Nominal income doesn't adjust for prices, is we take the CPI of the older time period and divide that by the CPI of our newer time period. Okay. So if I'm looking at nominal income, if I was told, do this one first. If I was told I wasn't given numbers, now first of all, if I was given values, I could give you any of these three values and make you solve for the fourth. I could also kind of just leave it conceptually and say, okay, if my real income is less than my nominal income, what must be true? Well, the only way that's going to be true, right, is if when I take my nominal income, whatever this fraction is, my real income is going to be lower. This fraction would have to be less than one. So if I know that, right, then I've got my CPI in the older time period over that CPI in the newer time period. If it's going to be less than one, I can kind of say with a little bit of algebra, oh, sorry, just want to do that. So that would kind of cancel. I multiply this by the CPI of the newer time period. What must be true if my real value is less than my nominal value, or real income is less than nominal income, is that my new CPI must be larger than the old one. So this is the idea that nominal income or nominal value doesn't control for prices. So it might look like our income went up, but once we control for prices, it's always going to be that if I have increases in prices, given the same amount of nominal income, my real income, the amount of units or that I can buy is going to go down, right? So if I know that relationship between real and nominal income, I can always make statements about um, my old and my new CPI, right? And then you could do the reverse, right? What if instead I told you that real income was greater? Well, then what must be true? I would go through the same kind of thing. What I would see is that old CPI must be greater than my new CPI, because in that case, this fraction would have to be greater than one. The only way that's true is if the old CPI is larger than the new one. Okay. Now I could take it one step further, and I could ask you, given this information, what has to be true, right? Well, if the new CPI is larger, remember the CPI is just trying to do a measure of average prices. So if average prices are now higher, what do I have there? I've got inflation. If my average prices are ever decreasing, well, then I've got deflation, right? So I can kind of start out with these statements about real versus nominal income and determine if I have inflation or deflation. I could also work the opposite way. If I know that I have inflation, I know real income will be less than nominal. If I ever have deflation, my real income would be greater than nominal. Okay. Excuse me. Any questions on that before we keep moving here? All right. Um, So the next thing we're going to do is dive into the daily quiz, and I'll probably add in some additional questions that you could be thinking about for Module 4. So we'll get a little bit of review of Module 4 here. Like I said, I think we'll probably run out of time. I won't have anything from Module 3 today, uh, but tomorrow I'll make sure that I've got a set of questions if nobody asks any that I worked through that are primarily, or at least start out with module 3. So if we go here, let's go to this. Oh, never mind. I thought I saw something in the chat. We'll go to the June 30th daily quiz. I'll go down here. I'll double check that I set the time limit. Yep. So I'm going to start this quiz right now. Um, we'll go down here, preview, and kind of start thinking about how I would solve these. Okay. So this is going to be primarily a review from some things that we talked about yesterday. In fact, I think this first one goes all the way back to Friday. So I've got four options, right? And I'm asking about which of the following is not true. So I'll kind of describe these as I'm kind of writing this out and kind of giving you a visual depiction. So if you have this pulled open, you can kind of hopefully split screens with when I'm working through and then kind of the potential answers that I'll be referencing. So here I was thinking about, when I'm thinking about this per worker production function, we were looking at the relationship between investments in the capital, and then we said here kind of the resulting output. Now, what is a measure of output, or what are we trying to measure output with? That was our real GDP. Okay. And we said that this per worker production function looks something like this. Okay. Um, so if I'm thinking about as I invest more into capital, right, when I'm at lower amounts of capital, then that change in output doesn't look too large here, but it's going to be relatively large to when I'm looking at higher levels of investment. That same increase in capital is causing a smaller change in output. Okay. And in fact, I'll kind of draw this out more dramatically. So there was also a question about, so I think one of the answers was, as we invest more into capital, the change in my output or the change in my real GDP is decreasing. The same would hold if we were looking at investments into labor and its impact on real GDP. So if I draw this out a little more dramatically, here I can see that that same increase in labor is going to cause a pretty large change in my real GDP, whereas at higher levels of labor, it's again trying to draw this to scale, that same change in labor, right, or investments into labor, is going to cause a really small change in my real GDP. So whether or not I'm investing into labor or capital, as I invest more, yes, my real GDP is always increasing, right? However, as I invest more, it's going to be increasing my real GDP, right? GDP is still going up everywhere here, but it's increasing at a decreasing rate. So both of those statements about labor and capital are going to be true, right? That as I invest more into either, my real GDP is increasing at an increasing rate. Okay. Now, the other two options that we were given there is if total factor productivity changes, let me just make sure I forget how much time. I want to know how much time is left here. Okay, we're good then. Um, so the other options were if I see total factor productivity increase, and I'm told the same amount of GDP requires more investment in labor, or the same level of investment in capital will result in higher GDP. So I'll kind of give you a visualization of that, and which we'll try to determine which one of those is true, which one is not true. So if I'm looking at kind of investment into capital, and here I'm thinking about the resulting impact on output or real GDP. So maybe initially this was my production function. Okay. After this increase in total factor productivity, we said we know that's going to shift my production function kind of upward. Right? So what that would mean is that at the same level of investment in the capital, right? So you can think about this was like after that total factor productivity increase. So that same investment in the capital before this is the level of real GDP it was producing. After this is the level. So what has happened is that the same capital investment after a total factor productivity goes up will increase my real GDP. So I believe that was one of the statements. So that's going to be the one that is actually, let me double check here that that's one of what the statement says from my memory. Yeah, as total factor productivity increases, the same level of investment in the capital results in a higher GDP. Now, just to kind of add this in, if I had a quiz or an exam question, I could also say what happens if total factor productivity decreases, right? And maybe instead, I ask you about labor. The same relationship will hold whether or not I'm thinking about capital or labor. So if I see a decrease, so this was kind of after an increase in total factor productivity. If I have a decrease in my total factor productivity, if I was maybe referencing labor here, what has happened? Well, the same investment in the labor now results in a lower level of real GDP. Okay. Any questions on that? And so we now know what the answer is. It's going to be the only one we haven't talked about. So for the sake of time, we're kind of running out here. So we just said what? As total factor productivity increases, the only one we haven't worked through, we showed that the other three are true. So it must be this one is going to be the correct answer, right? So we'll work through why, and then we'll work through question two together. But just for the sake of time, if you kind of opened up this quiz, as long as you're even watching this after the fact or attending live, I'm telling you kind of this answer here is going to be 16.7. We'll work through why, but that will give it to you so you have enough time. We've only got 3 minutes. I won't go through the rest of these explaining them and in that time frame. So 16.7, and then we work through all these. This is going to be the one that's not true. So make sure you're kind of getting that submitted. So we're now going to work through why that fourth option is not going to be true. So what that fourth option said was after a total factor productivity increase, right? So we had, and this would apply whether or not we're thinking about capital. I could also say labor. I think this specific example was talking about labor, but we could do either one. So let's say before, here was my per worker production function or my um, real GDP that corresponded to different levels of investment in the capital and labor. After a total factor productivity increase, so that kind of shifts our production function upward. Another way I can think about this is if I wanted the same level of real GDP, right? So I'm looking at the same level of real GDP. Will that require more or less of an investment into capital or to labor, right? Either one. Well, I can see here that initially this was the amount of labor that I would need, or we could have a different example. This was the amount of capital I needed. After that total factor productivity increase, I now require to get to that same level a lower amount of investment into either one of those factors of production. I could be asked about either one. So I think in that problem, it says that after this total factor productivity increase, we require more investment into capital or labor. No, we actually require less. Questions before we move on to the second question of that daily quiz, which I already gave the answer was 16.7 there. All right, so in that second question, oh, I missed something in the chat here. It says the correct, oh, sorry, I mixed. It is 17.6. I try to do this from memory and I shouldn't have. Um, I'll change it afterwards so it actually accepts either one. I'll kind of regrade that. I apologize. I should have looked at it before just trying to do it from memory. It is 17.6. So we'll actually work through it now and show why. Okay. I'll adjust those once again after class. I'll have it kind of accept either answer as correct. Okay. Um, so why is it 17.6? Okay. So if I'm looking at this production function, I've got total factor productivity, I've got capital, and I've got labor, right? So how would I solve for this Y or the overall output or the overall real GDP? So I'm going to use those levels or those numbers as we kind of work through this. So my initial, if I'm calculating real GDP or Y there, it was equal to total factor productivity times capital to the, make sure I'm getting this to match up here. What, zero point 0.4, and then times labor to the 0.7. Okay. Well, if I just told you these values, this would actually be a relatively easy question if I simply asked you what real GDP was. Okay. If this was real GDP, I just plug these values in. If I do that, I think I get 3,397.29. Okay. Now, this question doesn't simply ask for what real GDP is, it asks me for the growth rate if after that initial investment, I go from 200 units of labor to 300. Or no, sorry, not labor. If I go from, yeah, my capital investments go from 200 to 300. So the only change there is when I'm making this calculation now, I've got 10 times 300 to the zero point 0.4 times, sorry, labor, which was 200 to the zero point 0.7. If I now do this calculation, I should get 3,993.48. So I now have my old GDP, my new GDP. How do we calculate growth rates? Well, it's very similar to inflation. Inflation is measuring the change in prices. Growth rates are measuring that change in output. So if I wanted the growth rate as a percent, and I'll indicate this in the problem. So here we're working through it together. Um, Typically when we're calculating growth rates, we're looking at them as a percentage. In the problems you would see on the quiz or the exam, I'll specify, right, enter it in as a percent. Um, and so here, how would I calculate that? Okay. Well, the general form is going to be, I'll take whatever my new GDP was minus my old GDP, whoops, divided by whatever my GDP started out at, or my old GDP, and then multiply it by 100. So this should look very similar to when you're doing inflation. The only thing we really changed was instead of CPI, when we were looking at inflation, or sorry, yeah, instead of CPI that we were using to find inflation, to find the growth rate, we're using the GDP, the measure of output, as opposed to the measure in prices. So from here, it's just a matter of plugging these values in, right? So if I wanted to calculate the growth rate, I first had to find that new GDP. I then subtracted the old GDP and then divided by that old GDP and multiplied it by 100. That should give me that 17.6%. Okay. Any questions on that idea before we keep moving here? All right. Um, one second. So let's move on. So I think the second part of that question, It's not, I didn't ask you to put an answer in, but it says as a follow-up, what must be true about my growth rate in terms of GDP compared to the actual growth rate in capital? So one thing we'll notice, so if I calculated the growth rate, but instead of for GDP, I'm looking at capital. Well, my new amount of capital was 300. The old amount was 200. If I divide that by the old amount, multiply that by 100, I actually get that there was a 50% increase in capital in order to get that 17.6% increase in GDP. So that percentage change in capital will always be less than my percentage change in GDP because in all of these production functions that we're using, capital gets taken to a power that's less than one. So because of that, we're not going to go through the mathematical proof, but anytime I have an exponent that's less than one, that same percentage change in capital will get kind of scaled down so that it's always greater than that percentage change in my GDP or my growth rate. Okay. Um, what else? We got what, about 15 minutes. So I want to work through some other examples from kind of module 4. So let's say I'm looking at real GDP. I've got total factor productivity, capital to the point 4. I'm now going to complicate this a little bit. And instead of just using labor, we're also going to include in our model human capital. Okay. So if I do this, right, we kind of worked through an example yesterday in class, but the same kind of thing is going to apply not to just that capital and labor, but capital and human capital. So, or physical capital and human capital. So we said yesterday, if we had a 10% increase or kind of change in capital or physical capital, and we had a 10% change in labor, the one that is going to impact real GDP more, or kind of which one's going to impact real GDP more, was whichever one, right, kind of has a higher exponent. So if we look at the exponent on capital here, it's less than the exponent on labor. And so we know that the same percentage change in those, the one that's going to cause a larger change in my real GDP will be the one that has a larger exponent. Okay. If the reverse was true, then that 10% increase in capital would change GDP by more. That same concept would apply if I was comparing that 10% change in capital to a 10% change in human capital. Notice L and H here are getting raised to the same power. In fact, another way that I could write this would be like this, in which case I've got the same exponent on labor and human capital, so that kind of relationship should remain the same, right? The one that has a higher exponent is human capital compared to physical capital, so that 10 percentage change in human capital would have a larger impact than the 10 percentage change in physical capital. Okay. Any questions on that one before we keep moving? Okay. Um, I want to make a few more points here about things I could ask you specifically on the exam. Um, and just to kind of give some support behind why. So one thing you'll notice that we definitely didn't do yesterday, is what's true if I have a 10% change in labor and a 10% change in human capital. Which of those is going to have a larger impact on real GDP? Well, it would be whichever one has the higher exponent, but notice they're getting raised to the power of the same exponent. So both of these would cause the exact same change to real GDP. Okay. So exact same change to real GDP here because they're both being raised to the power of the same exponent. Now, an additional question I could ask you, and we worked through a numerical example yesterday, but we said total factor productivity increases are always going to be larger than that same percentage change in either physical capital, labor, or human capital. But why? Well, if you think about this, when I'm calculating my real GDP, I've got this production function. Essentially, anything raised to the one power is itself. So I could rewrite this here. So what did we say? We said whatever has a higher exponent, that's what's going to cause a larger change in my real GDP. So notice if the exponent on total factor productivity is 1, then that exponent of total factor productivity, every equation that we're using for this production function, we're assuming that we're using values that are less than 1 here. So this exponent of 1 is always going to be greater than these exponents on either capital or labor. So that same percentage increase would always cause my real GDP to go up by more if that changes in my total factor productivity. Okay. Then take this one step further. So if we have this idea, I'm going to get rid of human capital for a second just to kind of simplify this. So if I'm looking at my real GDP, and here I'm just going to do, oh, forgot A times K to the 0.4 times L to the 0.7. Okay, keep the numbers the same. Let's say simultaneously, I see a 10% increase, right, in the physical capital. I also see a 10% decrease, or I could think about this as like a negative 10% change in labor. What's going to happen to real GDP? Okay. Well, the 10%, which of these is going to have a larger effect, right? We said whatever has kind of the higher exponent, right? In this case, the exponent on labor is greater than the exponent on physical capital. Whichever has the higher exponent has a kind of larger effect on real GDP. So if I'm going to color code this, right? If we're thinking about how did this impact real GDP, this increase in physical capital caused my real GDP to go up. This decrease in labor caused my GDP to go down. If I wasn't told what those percentage changes were, right, I don't know that it was 10 for both of these, the answer would be I can't determine what that change in real GDP is. However, because I was told it's the same 10% increase and decrease here, they're not going to equally offset each other because that decrease in labor is going to have a larger effect because it's taken to a higher exponent. So we would actually know that that increase from capital is going to be smaller than the decrease in that labor causes in my real GDP. So ultimately, we could say in this case, my real GDP will go down. Now, if I don't know the percentage change in capital and labor, the answer would have to be, I'll use a code, just kind of this one. It depends, right? We can't say if we don't know that it's the same percent increase in both, or if we didn't know the exponents. Okay, excuse me. All right. So one other form of this equation that, or kind of the type of question I could ask you is, and I'll just rewrite it out again. So my real GDP that we had, the equation we were using, total factor productivity, K to the 0.4, L to the 0.7. Okay. I could kind of combine some earlier concepts, which were if I want to know what my current level of capital is, it's going to be the older time period's amount of capital plus the investments I made, and then minus the amount of depreciation, right? Or the physical capital I was losing. So if I ever gave you a problem where I said something like, if investments, right, are less than depreciation, what's going to happen to my real GDP? Well, if investments are less than depreciation, this value is going to be negative, in which case my new physical capital is going to be lower. If my new physical capital is lower, that's going to cause a decrease in my real GDP. Now, I could also couple this with something like if I had simultaneously, right? If I had that depreciation was less than my investments, but also total factor productivity increased, right? Well, there, total factor productivity goes up, which would increase real GDP. Without knowing the actual percent changes, the change in real GDP would be indeterminate. So the answer isn't always indeterminate, right? In fact, if I had a second scenario where instead of looking at capital, let's say I was looking at labor, right? So if I've got real GDP and I just kind of use that same equation, let's say, so if we know that equation for capital, we also have a similar equation for labor, which is its current amount of labor is the previous amount plus our labor inflows minus our labor outflows. So I said you can think of like inflows and outflows as employed versus unemployed, right? That's not completely everything because like this could technically we could have human capital and complicate the model, but for the sake of what we're doing, think of this as like the number of employed, newly employed, and the number of newly unemployed, right? The people kind of leaving who are not working any longer. So if I knew that my outflows were less than my inflows, what would be true? Well, if inflows are greater than outflows, this would be a positive amount. My new level of capital would be higher, or sorry, the new amount of capital. The new amount of labor would be higher, which would increase my real GDP. If simultaneously I had an increase in total factor productivity, that also increases my real GDP, in which case the answer is not it depends. I definitively know if these things happen simultaneously, that real GDP would go up. Okay. Any questions on that idea or that question? So relative to quiz number two, these problems I'm working through here, the quiz is likely to more break down each one of these concepts individually. So maybe I just say what happens to the new level of labor. There's another question, how does a change in labor impact real GDP? But then also kind of there's another question, how do simultaneous changes impact real GDP? I'm throwing all those concepts into one question. So the quizzes might break these down piece by piece. The exam is much more likely to kind of combine those concepts into one question. Okay. Um, so that should do it for today. Once again, I didn't get a lot of emails. I had some from the earlier section. I don't believe I had any from this section about questions that you want to see worked through, or I answered them via email and then they didn't want to see them work through in class. But try to look through those practice problems, old quiz one questions, or if you just come up with like a question like what would happen if this was the case, bring those to tomorrow's class. It makes it more productive and effective, not just for those who attend live, but everybody. I have a set of questions I'll work through. Like I said, we didn't really do anything with module three, so I'll try to bring in some more module three questions tomorrow. If people don't have questions specifically they want to see worked through. Other than that, um, I don't think I have anything else to say. Look out for that announcement about the first midterm. I'll end the recording here. If you have any questions, those of you who are still here, feel free to ask once we're done or once I hit stop recording.